Yes, I think everybody is ready. Okay, cool. So let me introduce you Andrey Sobol, developer from Pandora Boxchain project. Give applause, please. I don't know, blockchain stand-up comedian as well.
No, no, no. Not blockchain startup comedian. I'm Andrey Sobol. I worked in Pandora Boxchain. We think about parallel computation. We try to implement protocol for parallel computation, and actually, I work right now in algorithm of consensus. I think about on-chain randomness and other cool stuff. So that's me. And today I will talk about is Web3 bullshit? Yes, thank you very much. Also, it's a joke, but seriously, is Web3 is bullshit? No, thank you very much. Actually, if we will talk about Web3 seriously, we need to know what Web 1 or Web is. It's just hypertext and uniform source locator. Tim Berners-Lee, inventor of Web, they say that it's read-only web. That means that people just open a web page, read information about some stuff, click to hyperlink and go to another page and just read and just get information. That's how Web 1 look like. And what is Web 2? Web 2 is web of its network, and this network in this network users can communicate between each other. They can buy some stuff. They can post text, video, photography, and other stuff, and they can communicate between each other. They can message to other user, and but they can do it with centralized server. For example, Twitter. They can just open a web page twitter.com and they can publish some tweet, and other people will read this tweet if in Twitter server if we have no error in Twitter server. Also, it's Uber. People can get taxi using app, and driver can connect to Uber and get a job. And communication between driver and client, we have central server. The same things in Dropbox. So what is Web3? Web3, by the way, disclaimer, when I talk about Web3, I talk about distributed understanding of this word, because if you try to find Web3, you can get some other concept. It's not only like Web3 Foundation interpretation of these terms. So you can just get another things about this word. So in Web3 we can get some distributed network, and people can communicate between each other without trusted gateway, without trusted server. And for example, it's magic P2P Uber. You can see customer, you can see driver, and you cannot see some centralized server. For example, it's Workit protocol. It's Bitcoin. You can see receiver of money. You can see sender of money. You can see miner, which create block and update state of network, update ledger, and the miner between each other reach consensus or reach agreement, and in whole network we have the same state. So you can see that right now our bank system look like distributed network, but it's wrong, because if bank 2 go down, if sender cannot connect to mobile application of bank 2, they cannot send the money to receiver, and we have single point of failure. But in our current bank system, we have not only one point of failure. We have bank 1, which is point of failure. We have bank 2, which is point of failure. So when developers think about Web 2, developers think about Web 2, they think about UI, user interface, about application, and about backend, a server backend. If regular developers think about Web 3, they think about UA, they think about application, and they think about smart contract. But it's totally wrong, because we have UI, application, smart contract, and we can see P2P network, we can see consensus, we can see accounting format, because it's like iceberg, and you can see only head of the stuff. But we need to think about all of this part of technologies. If we try to create Web3 protocol, we need to think about virtual machine, about cryptography, about smart contract language, about layer 2, for example, side chains, drive chains, sharding, about state channels, about governance in our protocol. So let's talk about P2P. Which problem we have? By the way, I forget to say that all of this stuff, cryptography, consensus, accounting format, it's all about trade-off. For example, we can reach accountability in our distributed network, or we can reach only privacy. So you can select, okay, I want privacy, or okay, I want full accountability in network. Because as you know that if we have problem in, for example, in bulletproofs in Monero, people can just print money if they find bug in bulletproofs, and nobody can find it because we have no accountability in Monero. So let's talk about P2P. You can see right now it's a Bitcoin core implementation, and what you see, it's DNS seed server, 7 DNS seed server, which maintained by Peter Todd, Luke Dashir, Matt Corallo, and other Bitcoin core guys. So what we get if this 7 server go down? New client which connect to Bitcoin, they will not find any node, only new client. Old part of network will continue and block propagation in this part of network will work well, but we cannot get new nodes in this network. So also IPFS developer think about and create other protocol for reaching address in peer-to-peer network, but it's not silver bullet, so we have this problem right now in Bitcoin, in other distributed network. Let's talk about consensus. Consensus, it's all about trade-offs. So you can get only low latency finality, low overhead, and small numbers of nodes. Or you can choose, okay, I want high latency finality, I have low overhead, and I have large numbers of nodes. Another point in this diagram, it's low latency finality, high overhead, and large number of nodes. So you can choose. You can get only 2 good point and get 1 bad point. But we have some magic things which name it as random. So if we use random in our consensus algorithm, we can reach some part of characteristic of large number of nodes and some part of characteristic of high latency finality. For example, we can choose small set of nodes in big set of nodes, and we can say, okay, these nodes can update ledger in this time. So which random algorithm we have right now? We have naive random algorithms. For example, not just push to network random number and we compile it to one random number and we use it for selection, leader election. Another, it's bad protocol because last node can cheat. Another approach is commit reveal scheme. That means that not just push hash of random and then not reveal random, but we have problem in this protocol because last validator can select, okay, I want to reveal my random or I don't want to reveal my random, and the last validator select randomness between 2 variant. If we have a set of nodes which conspire between each other, they just say, okay, we can combine random which we need in our results. We will push this part of our random and we don't push another part of our random, and these nodes can select random which they want. Another approach of random election is proof of work. We can think about proof of work as distributed lottery. That means that if you want to participate to proof of work randomness, you just buy ASICs or you just create ASICs and use it for generation hashes for doing proof of work. You push your result to network, and network can validate that you create good result, and they can accept blocks with proof of work. Another approach of random, it's verifiable delay function. I think it's proof of work 2.0 because we have a new cryptographic primitive, which means that verifiable delay function, which means that we have we can calculate some stuff in very long time, but we can check it very fast. So that means that we have a big set of times that we can send our random and nobody can recalculate it, because we need higher resources for this stuff, and we can get honest random. But if somebody can create fast ASICs for this stuff and don't show it to market, market will think that, okay, we have honest random, but this guy can cheat. Another approach of random is threshold cryptography, and for example, Shamir secret sharing. That means that guy can divide secrets to small part of secrets, and we have no last guy which can publish it or unpublish, because for example we have Shamir secrets 3 of 5. That means that 3 guy can recover secrets. It's pretty cool stuff. Another stuff, it's BLS signature. That's very similar to Shamir secret sharing. I forgot what I want to talk in this slide. So, threshold for leader election. In distributed network, we have problem which name it as Sybil attack. So that means that one guy can create many identities, many nodes, and try to attack this network. So we need a threshold for participant, and we get a Sybil attack resistant network. It can be proof of stake. That means that we have internal stake coin, and people who have many coins, they can participate to block creation procedure. Another stuff, it's proof of work. It's in the same time it's random protocol and leader election protocol. Another thing, it's proof of reputation. That means that in network we have reputation. You have, for example, reputation. You cannot send it to other user, but you can use it for block creation. Let's talk about second layer. Side chains, drive chains, sharding. It doesn't work right now. We have some prototypes. We have some ideas of sharding or drive chains, but it's not product ready. Right now we have only federated side chains. For example, a rootstock. For example, liquid or proof of authority network. It's sidechain for Ethereum. So right now we have no trustless solution for this in this field. Another thing is state channel. Right now we have Lightning Network, which I think product ready. We have Raiden Network, which have good prototype. We have Plasma, Plasma Cache, Plasma Prime, and another Plasma variant. But right now Plasma is not product ready. And we have so many limitations in this protocol. For example, we cannot implement Turing complete language in Lightning Network, in Plasma right now. We cannot create a smart contract with state. And if some protocol designer thinks that, okay, I just create simple variant of my protocol and I will update it, but right now it's very limited solution. Fundamental trade-offs in smart contracts. Let's talk about smart contracts. The main fundamental trade-off is simplicity and complexity. That means that you can get only small verifiable virtual machine or smart contract language, but you cannot implement complex code or complex program in this smart contract language. And in another side, we have something like, in another hand, we have something like complex Turing full language, but nobody can create full audit of smart contracts language and smart contract of Turing complete smart contract language and Turing complete smart contract application, because it's impossible by design. And so you can choose, I want security or I want a lot of features. Also, let's talk about governance. Governance in distributed protocol in Web3, it's very hard part of designing Web3 protocol, because right now we have no good example of governance, because that's look like Bitcoin governance. And if we talk about Ethereum governance, that's look like Ethereum governance. So yeah, you can see it's pretty cool picture. Actually, when we start to think about Pandora, we see, okay, we will create UI applications and smart contract. We will deploy it to Ethereum network, and we get product. But right now, we think about consensus algorithm. We think about randomness, about other stuff, because we have no silver bullet in this field right now. Let's talk about economic problem. First of all, I want to talk about trust, because in centralized system we have trusted authority. We trust Twitter. If we use Twitter, we trust Facebook. If we use Facebook, if we don't want to use Facebook, or if you don't trust Facebook, we just delete account as Dima. So first of all, when we create a Web3 protocol, we need to think about trust. And we need to think about cost, because distributed system, if you want reach decentralization, you need to pay more. You need to pay more in time, in money, in infrastructure. And it's, by the way, I think it's fundamental trade-off between cost and trust. If you want something trustless, you need to pay more. If you want something costless, you need to trust somebody. Let's talk about network effect. We have some application which makes sense only if many people use it. For example, Twitter. If or Facebook. If very small part of your friend use Facebook, you have very small incentives to use it. If you have big community in Facebook, you have strong incentives to use it. And we have a bootstrapping problem, because if we talk in game theoretic slang, we have like two Nash equilibrium. For example, all people use Facebook, or nobody use Facebook. All people use Bitcoin, or nobody use Bitcoin. So we need to think how we can bootstrap our product, because centralized company can spend money to marketing, but in decentralized protocol we have no entity which have so big incentives as, for example, Facebook corporation. that's trade-off between native coin or maximalism, Bitcoin maximalism or Ethereum maximalism. That means that money is the most liquid product, is the most liquid commodity. And we have only in normal situation we have only one money. For example, before we get fiat system, we have only gold and silver. Yes, but if we compare capitalization of all golds for example, and all silver, you can see that people choose one product for money and use it. But right now we have no side chains or state channels, good solution. And we need, if we want to implement some distributed network, some Web3 protocols, some Web3 application, simple way that we just create our coin. Incentivization. Right now, we have maybe 1 million web or software developers. But how many specialists in game theory, in incentive economic we have right now? I think maybe 2,000, 3,000, 5,000, but not million. So first of all, we need to learn economics for designing Web3, and because we have so many computer science specialists, but we have no economic specialists which can think about incentive mechanism, about crypto economics and other stuff. So just learn game theory, just learn economics, and then our Web3 don't look like this. We get something more stronger than this picture. Thank you very much.
Thanks, Andrey.
Oh, I forgot that say thank you very much in Czech language. Děkuji.
Děkuji, Andrey. Yeah, we have time for a couple of questions, if anybody. No, seriously? Okay.
So thank you, Andrew, for the deck. I'm this that guy that asks stupid technical questions.
Okay.
Actually, I have only one question to you as a developer of the Pandora. Andrew, when the mainnet?
Oh, right now we have testnet. You can test testnet, and we can right now we can publish mainnet, but with small set of features. And
Publish mainnet?
Sorry?
Sure, publish mainnet.
Right now we can, but we don't want it because we need to implement so many features, and then we will publish our mainnet and we will run our mainnet.
So how can I check your testnet?
You just go to github.pandora boxchain to Pira contract and other stuff, and you get instruction in readme.md.
I will actually look at it. Thank you, Andrew.
Thank you.
I saw one more hand, but
Hi, Andrey. Thanks for the nice talk. So I just wanted to ask one question. So you've mentioned a number of problems here we have in Web3.
Yeah.
Some issues that we have to solve.
Yeah.
What do you think are the chances that in the near future all of these problems will be solved, and what do you think would be some kind of like an estimated timeline in which we can expect a full Web3 solution?
I don't know. Is Bitcoin is full Web3 solution? I think yes. So right now we have Bitcoin, which worked but we cannot scale it, but it's work. So I don't know how many years we need to scale Bitcoin, how many years we need to scale Ethereum, because I meet Vlad Zamfir maybe 3 years, maybe 2 years ago, and ask Vlad, when we can get Sharding and Casper? They say after half of year. So I don't know.
So you think that the biggest problem is scale?
Yeah,
Okay. And the only.
scale, and privacy, but scale is the most.
Okay, thank you.
Thanks. Any other questions? Yes.
Hey, where did you get the bag?
Yeah,
The backpack, where did you get it? No, your
internet. Welcome to the internet.
Okay, seriously, the question is, you mentioned proof of work, but you didn't mention proof of stake, so don't you think proof of stake is like something to consider? Or maybe delegated proof of stake?
Also, in Pandora Boxchain right now, we have prototype of proof of stake algorithm, which named Prometheus. We write paper about it. It's proof of stake, it's proof of stake DEG with our random algorithm. So when we finish this work, we will launch it and test it, and maybe we get some stable proof of stake protocol.
Okay, thanks.
I think it was the last one. Yeah, thanks, Andrey. Дякую.
Thank you very much.
So we will have now maybe 5 minutes break again, and we have one more speaker. It's Anton Akentiev from Moscow. Yeah. Yeah.